Hi and good morning. My name is Muhammad Hakimi bin Muhammad Razif. So today I will explain about the experiment in subject of bioreactor operation, which is the topic is the investigation of volumetric mass transfer coefficient via bioreactor operations. So first and foremost we go to the materials and method. So materials we use is neutron broth, neutron gas, and air. The equipment we use is bioreactor, air compressor, and nitrogen gas tank. So the first step is the bioreactor was filled with 1 liter neutron broth, and PO2 probe is used to calibrate the bioreactor. And after that, dissolved oxygen was supplied by using the air compressor until it achieved the 100%. After that, the air compressor was reconnected and the nitrogen gas was supplied. The fourth step is uh, when the dissolved oxygen returned back to 0%, the air supplier was reconnected, and then uh, the CL value was recorded every 40 seconds until it reached the constant point. In this experiment, we use different airflow rate, which is 1.0, 2.0, 3.0, and 4.0 liter per minute with the same agitation speed. We use the agitation speed of 100 rpm. And then when uh, the last step is we plot graph of ln C star minus CL against times. So next is the precaution steps we must take and take serious to avoid any error in the experiment. So the first one is never block the exhaust to pressurize the vessel, because when we block the exhaust, uh, pressure in the reactor will increase and explosion might occur. Next is keeps electrically steady inside mains equipment as far away from reactor as possible, because we don't want any unnecessary situation happens. Next is proper personal protective equipment, especially safety goggles should be worn during handling the reactor. Ensure that the level of dissolved of oxygen supply is achieved 100% before proceeding step. Because if the first step is did not succeed, then the next step cannot be proceeded. Next is to avoid vessel stress cracks. Never over tighten the vessel, because we don't want if the vessel to put inside the validator is broken down, so the experiment cannot be handling. And then lastly is we must sterilize all the equipment for handling the experiment to avoid any contamination. Next is the results we obtain from the experiment we handling. So in this slide we see the agitation speed is 100 rpm. We have four different airflow rate, which is 1.0, 2.0, 3.0, and 4.0 liter per minute. Then we have value of KLA in per second and per hour. For 1.0 airflow rate, the value of KLA is 0.0029 per second and 10.44 per hour. For 2.0, the value of KLA was 0.0064 per second and 23.04 per hour. Next is the airflow rate of 3.0. The value of KLA was 0.0063 per second and 22.68 per hour. And then the last was the airflow rate of 4.0 liter per minute. The value of KLA was 0.0101 and per second and 36.36 per hour. So this is the graph we obtain after we collect all the value of Ka in different flow rate liter per minute. So the discussion is we want to discuss about the factors affecting the KLA value. So in the experiment, we know that the variable that we change is the airflow rate. So in the experiment, the factor affecting the KLA value was the airflow rate. The higher the airflow rate, the shorter the time taken for the media to saturate with the oxygens. Means that the high flow rate allows more oxygen to enter the bioreactor for a particular time than the lower flow rates. The media in the bioreactor will be concentrated with oxygen more rapidly than air flow rates. So basically, increasing in air flow rates will increasing in the KLA value. So other than that, the factors affecting the KLA value will the size, properties of the liquid or medium, and the agitation speed. Agitation speed is same with the flow rate, which increase in value. Decrease bubble size, decrease in the surface area will improve the KLA value because there's no bubbles inside the reactor. Okay, that's all. Thank you.